Hello, just quickly, right after I just did that one question for the previous video I just uploaded, I came across another question, and it was saying about something related to y equals -2 natural log of x. And it came up to my thought, what is the difference between the negative being on the outside compared to the negative being on the inside with the x? What is the difference? Well, we can consider this whole thing as negative a. We can consider this whole thing right here as a. And we can consider this whole thing here as negative x, because how to really differentiate if it's a negative a or negative x is if there's a negative in front of the x, it's a negative x. If there's no negative in front of the x and it's on the outside, then it's a negative a. Right, really simple. You should be able to get that in your head. I just use a as a coefficient, not coefficient, but as like a variable that is like any variable. It can be b, c, whatever. I just like using the letter a. But yeah, so if x is negative, it's negative x. If it's not, and the whole thing is negative, then it's negative a. And what I found was, I'm not too sure if this is true or if it actually applies for all things, but for what I've seen for exponential functions and logarithmic functions, it seems really true to me that if the x is negative, then it reflects it in the y-axis. If the whole thing is negative, the whole function is negative, it reflects it in the x-axis. So let's see that. So let's look at a logarithmic natural log, and we can see that the normal function is a red line. And we see that a normal logarithmic function behaves like this. So you can see here, it behaves like that. And we can see here, the purple one, that it has a negative in front of the x. So here, negative in front of the x. And negative x reflects in the y-axis. So we can see that it actually does reflect in the y-axis. It goes this way now. Cool. And then we can see a negative in front of the whole thing, so negative a. And negative a states that reflects in x-axis. So reflects in the x-axis, and so it's going down. So it's going this way now. It's cool. Makes sense. It all logically works pretty well. So if sometimes you're always looking at a logarithmic or exponential graph, and you just don't know how it's gonna look like, because there's like a -2 natural log x, and you're like, well, does it reflect in the x or y axis? Now you know. If it's a negative a, it reflects in the x-axis. If it's a negative x, it reflects in the y-axis. Now let's look at another example for the exponential functions. Here, the normal one is a green. So, green. And we can see the green one, as a normal exponential function, it should behave like this. And so it does. It behaves like that perfectly. And we can look at the other ones, which is a blue. So a blue line, y equals negative a. So, because negative e to the power of x is negative a. And the red one is here, which is e to the power of negative x, right? So that reflects in y, and this reflects in x. And so negative a reflects in x, so the normal one of going like this is now reflected and going like that in the blue line, because it's reflected in the x-axis. And the red one, which reflects in the y-axis, follows the thing. So it goes. So the normal one looks like that, and it is reflected in the y-axis, and it looks like that now. Pretty interesting. Not too sure if this applies for everything, but for what I've seen right now, for the logarithmic and exponential, it seems so. Thank you for listening. Have a great day.